DPL Closure and Joints Reports, CAD Drafting Tips for Closures and Joints Data. Welcome to this training video on drafting plans using the DPL CAD Standards template and tools. Accurate drafting is essential for producing complete and reliable closures reports, minimizing errors, and reducing the need for edits and acknowledgements. In this video, we'll share some best practices and common pitfalls. When your DWG files are drafted to the LSSA DPL CAD standard, the closures created from that data are both accurate and comprehensive. This streamlines the plan's lodgement process and reduces corrections. Here are 5 essentials to get right from the start. Layers. Use the correct layers for line work and parcel identifiers. This is critical for data and parcel creation in the closures report. Road width and bearing labels. Incorrect placement of bearings and road width labels in roads can result in missing bearings in closures. Survey marks. Place marks correctly and ensure proper connections to support complete joins. Running chainage. Create and position chainages correctly to support parcel and joins data. Polylines for parcel boundaries. Do not use polylines where distance, bearing or chainage labels are present. This will result in missing data in the closures report. Common errors and how to fix them. Let's look at some examples of these top 5 essentials. Starting with layers. If parcel lines are placed on the incorrect line layer, this can result in parcels not being created in the closures report in the way that we would like. When parcel lines for allotments and lots are not on the L parcel layers, then the parcels created are usually the wrong parcel type. In this example, the parcel lines were placed on the L abut layer, and therefore construction parcels have been created instead of allotment parcels. We have 4 construction parcels in this example. In order to fix this, we would need to go to the DWG file and update the layers. So we would have to change the layers that were sitting on the L abut layer to the L parcel layer. Once the layers have been updated, then it's just a matter of saving and re-uploading the DWG. And this is what our corrected drawing looks like when we re-upload it and open it in closures. So we've got 4 allotments, 13, 14, 15 and 16. And they've been created as parcel type allotment and not construction. The next example is when a parcel identifier has been put on the wrong layer. In this example, we can see 3 allotments have been created and they have been identified allotment 13, allotment 14 and allotment 15. We know that there should be 4 parcels in this plan, 13, 14, 15 and 16, but allotment 16 has not been created. Instead, we have a common property parcel that's been created in its place. If we have a look at the DWG file, we can see that 13, 14 and 15 have all been placed on the right layers, but the allotment identifier for 16 has been placed on the A road layer. And this is why our parcels haven't been created. In order to fix this, then this identifier would need to be put onto the correct layer, saved and re-uploaded into Salus DPL. Once the corrected file has been uploaded, then we can see that DPL closures will process it correctly and we end up with allotment 13, 14, 15 and 16. The next example for essential drafting tips is road label placement. In this file, we can see a couple of versions of road labels. The first one's been placed correctly in the middle of allotment 505 here. We've got a bearing label 85 18 30 and it is very close to the road width label. Over on 504, we've got a bearing label at the top of the parcel and the road width label at the bottom of the parcel. These two labels are not close enough in order to be associated, and when the data is processed from the file, it will only assign the bearing label to one side or the other for each of these lines along the road. We can see that in the closures report, where we have a bearing label and a road width label close enough in order to be associated with the road, and it has validated the bearing against both sides of the road. Where we have just the one bearing label in the middle of the road and no road width label, then unfortunately we've only been able to assign the bearing to one side of the road or the other, and that's the case here and further up the road here, where we just have a bearing label but no road width label. And this is the same for easements where you might have easements with parallel lines. If you just provide the one bearing label in the middle of those parallel lines, we'll only be able to associate data with one line and not both. In the case where you don't have a road width label to add to it, the bearing labels will need to be provided for both sets of lines. So you'll need a bearing label for the top and a bearing label for the bottom line. The next drafting tip is in regards to survey marks. To reduce missing survey marks in the joins reports, ensure the connection line geometry matches the corner fixing details in the reference marks box. So this connection line here, we've got a length and an angle, and that should match our reference marks box with the bearing and the distance. If you are using true and exaggerated marks, ensure that you do have the corresponding lines. So if there is a true line connecting the survey mark, the true survey mark to the corner, then there must also be an exaggerated line. Make sure that connection lines are snapped to the center of the survey mark block. Running chainage, how to get it right. It's important to use the latest template and the latest chainage block. You can tell if you've got the latest block loaded in your DWG because the name of the block is chainage in uppercase, and you can use this to verify you are using the right one. It's also important to have the coordinates listed under the attributes, and those coordinates relate to the vertex along a line that you are trying to reference with that distance. As I said, chainages must refer to a vertex along a line, otherwise the polygons can show with missing dimensions. In this example here, this chainage block 103.55, the coordinates are referring to the center of this peg. The line that it's referring to does not have a vertex and it's not relating to that. Therefore, this chainage was missing, and in this example, the closures report was unable to create this construction parcel because it couldn't verify the distance 103.55. Another important factor is to check that abuttal lines are snapped to connection lines and parcel boundaries along chainage runs. We do find that sometimes the extract files are used, and this can cause a slight mismatch between a connection line and an abuttal line, and any break within the line could be enough to cause this chainage run to not be able to be validated along the full run. Check that the angle of the geometry of the line along chainage runs is all the same. So in this case, we've got consistency of angle across all of those lines in that chainage run, and that way we'll be able to go from distance to distance along the run. Drafting tip number 5, polylines and natural boundaries. Avoid polylines for parcel boundaries when distance and bearing labels exist. So for a line like this, which is a polyline in your DWG, which has a distance label, has a bearing label, and in this case has a chainage label, our data processing will struggle to be able to validate the distances against those lines as they are connected to each other. And therefore, validations will fail for these lines. And in your closures report, these lines will show up as missing data. There is an exception to this, and this is where splines have been used for natural boundaries. With splines in closures, our processing will try and reconcile that line and create a series of very small lines and place a point number at the start and the end of each one of these lines. It creates a lot of noise in your closures for these parcels as you end up with literally hundreds of lines and hundreds of points and no label data to verify against each one of those lines. I think in this file there's over 180 small lines. In these instances, we would recommend that you go back to your DWG file and change this spline for a polyline. Use a fairly low accuracy. In this case, I think my accuracy was about 12. It still has its variation. It shows the shape fairly accurately, but it won't end up with hundreds and hundreds of very small lines and points along this boundary. This will also benefit the time it takes to process the DWG file once you upload it to DPL. DPL processing has a really hard time with splines and takes a lot of processing power to come up with those hundreds and hundreds of very small lines and points. So we would recommend that with your splines, you replace them out with simplified polylines and upload them. Some additional drafting practices to help with data processing for your closures reports. Draft a single diagram in model space with one set of parcels and one set of parcel identifiers to prevent duplicate parcels in the closures reports. Ensure that the MGA zone in the title block matches the coordinates that the geometry of the diagram has been drafted in model space. If you are required to show a second bearing datum, show it on the A general layer on the sheet, not within the title block. Regarding double and hidden lines, double and hidden lines will create missing distance labels in the closures report. It's best to delete duplicate lines. By applying these standards with correct layers, clean line work, accurate chainages, and disciplined identifier usage, you will consistently produce complete closures reports and enjoy a smoother lodgement process.